For our next example, we're going to demonstrate how to create your own overloaded methods. And basically, the way that you do that is by simply defining multiple methods within your class that have exactly the same name but different parameter lists. Now notice I said nothing about the return types of the methods. The return types do not factor into the overloading resolution, if you will, that the compiler performs. So in this simple example of a class called method overload, we have two different overloaded methods called square. One here at line 15, which is a static method called square that returns an integer and takes an integer argument, and one at line 23, which is also a static method called square that returns a double and takes a double argument. The first lines of these functions are identical with the exception that the first one takes and returns an integer and the second one takes and returns a double. And the compiler can figure out which version of these to call based on the argument that's passed to the function at the function call point or the method call point. So here at lines 10 and 11 in main, you can see that we're calling the square function two different ways, one with a whole number and one with a floating point number. And if you hover over the whole number, you'll see that it thinks that this whole number literal value is of type system.int32. Now system.int32 is the .NET framework's data type that is used to represent an int in C#. And similarly, when I hover over 7.5, it thinks that's a system.double, and that's the .NET framework data type that's used to store a double in C#. So in the first case, it thinks that I'm passing in an int, and in the second case, it thinks that I'm passing in a double. And when I hover over the first square method's name, you see that it tells me in the tooltip that the version of square I'm using is the version that receives an int. And when I hover over the second square method call, you can see that it's saying that I'm going to be using the version that takes a double in that case. And to prove that these are calling the proper versions of the functions, in the version of the function that takes an int, we say that we called square with the int argument, and then we display that value. And in the case for the double version of the function, we say that we called it with a double argument and then display the value. So if I stop there for a moment, we can go ahead and run the program. And in the first case, we can see that we called square with the int argument 7 and produced the value 49. And in the second case, we called with the double argument 7.5, and we produced the result 56.25. Now, as you can see here, in this case, the compiler was able to resolve what version of the function should be called in each case. If I pass different types of arguments to the function, but I don't have different functions to receive them, so for example, if I comment out the int version of the function here for a moment, now I only have a square function that receives a double. And in this case, the program is still going to work, but you'll see when we call the first square function with the value 7 that it called the version with a double argument, which was the whole number 7. Now the reason that works is that, as we discussed earlier, C# has some promotion rules that allow certain values to be promoted to other data types, and an int can always be promoted to a double, which means any function that receives a double can also receive an argument of type int as well. And the reason that it's still producing just the value 49 is that trailing 0 values are not displayed by default in C# unless you explicitly tell it to display the decimal point with digits to the right side. So when I calculate the square of 7 with just the double version of the method that we had down here, I'm getting back 49.0, but the 0.0 is basically being truncated for display purposes. It is truly a double value that is coming back though. And as you may recall, if you wanted to force it to display something in floating point format, what we could do is put :F here to indicate that we want a floating point format value to be displayed, in which case you'll get 2 digits to the right of the decimal point by default. Now I'm going to uncomment the int version of the function now, and I'm going to comment out the double version of the function. And when I do that, I now get an error in my code, and the reason for the error is the fact that I'm trying to take a double value and pass it into a function that receives an integer. And a double, when you turn it into an integer, is going to lose data. In particular, we would have to truncate the 0.5 in this case, and therefore the result would certainly not be the 56.25 that we expect when you square 7.5. So in this case, the compiler is generating an error because the promotion rules are not satisfied. I cannot promote a double to an int. That would actually be a demotion and a loss of data, and therefore C# automatically gives you a compilation error. You could force this to work if you put a cast operator, in front of the 7.5. So if we said treat 7.5 as an int, now it will compile and it will call the square of int function, passing in the value 7 because it'll actually truncate off the 0.5 before the call occurs. All right, so that's a demonstration of the fact that just because you have overloaded methods does not mean you can pass whatever you want into a given method. You still have to be subject to the type constraints that C# provides. Now, I mentioned when we first showed you these two overloaded methods that the key part of the method for overloading purposes is the name of the method and the parameter list. So we have square of int and we have square of double. The return types do not matter. So for example, if I were to change the parameter in the second version of square to an int, now I'm going to wind up with error messages once again. You can see here that it is saying there's an ambiguous call between the following methods, square of int from method overload and square of int from method overload. And the reason is it doesn't know which version to call because the only difference between these two methods right now, as far as the compiler is concerned, is the return type int. You cannot have overloaded methods that differ only by return type. You must have different parameter lists or different method names themselves. So one of the benefits of having overloaded methods is I don't have to name these methods awkwardly. I can simply say square and give it the appropriate parameter types instead of having a function named square of int and a separate function named square of double and then having to write the code differently depending on the types of arguments that we're manipulating. So it basically makes coding a lot more convenient for the users of my class because they know that calculating the square shouldn't matter which numeric type it is. It should just be able to handle the different numeric types.